Hi, my name is David. This work has been done in collaboration with my colleagues Avi and Pavel. All three of us work for IBM Research and we are based in Haifa, Israel. Today I'm going to share with you some experience from our journey into orchestrating media-intensive services in 5G Edge. I will start by giving you some background and motivation, and then I'll talk how we used Argo and Knative in our project. Then I'll show you a short demo and provide some concluding remarks. This work was part of an EU Horizon 2020 project called 5G Media. As you can see, there have been many partners in this consortium. We started in June 2017. It was almost a 3-year project. We've been developing a programmable edge-to-cloud service virtualization platform for media-intensive application in 5G networks. IBM's focus in this project was on integrating serverless technology into the platform, helping the use case partners to leverage it for applications and harmonize it with the standard management and orchestration approaches such as Etsimano used by telcos. Also, we've been an integration partner responsible for tying bits and pieces together so that they would play out nicely. So naturally, this included lots of orchestration work, both intra and inter use cases. So let's define our problem first. We want to facilitate third-party applications deployment at the 5G edge. We want to do it cost efficiently with instantaneous elasticity and have fast time to market. It's difficult to achieve with traditional VMs. We don't know in advance where and when to deploy them. We cannot just deploy them everywhere in the edge waiting for events that may never come. VMs are notoriously difficult to right-size. Scaling out might be a problem. Scaling in might be even a greater problem. Pay-as-you-go is not really what happens with VM. And there are many problems related to infrastructure. So, serverless. Many media-intensive applications are session-based and event-driven. So what serverless can potentially give us is an ability to spawn CNFs, container network functions, just in time, when needed, and for the exact time duration they are needed. And it will be portable, and it will take away the infrastructure issues. So these are the use cases that we've been looking at in this project. TeleImmersive Media, we'll take a closer look just in a second. Remote media production, you're going to see a short demo of it, and ultra high definition CDN. That's an extremely interesting use case where we dealt both with VMs and containers, but obviously I don't have enough time to cover it, so we are not going to discuss it today. Just to emphasize, IBM was on the infrastructure side of things. The applications have been developed by other partners. All right, so TeleImmersive Media, it's a use case family actually, rather than a specific use case. In 5G Media, we use a TeleImmersive Game as an example of such an application, but this was just a demo to play with. Very briefly, there are 2 players. So here are 2 players. Each player is in a specific geographical location, but they are close enough and use the same 5G media slice. Each player is surrounded by 4 cameras producing a time-varying mesh stream. The players are embedded into a virtual world in which they can freely move in any direction. The players interact via a CNF, container network function, called virtual broker, vBroker for short. The broker starts at the beginning of a gaming session and leaves throughout the session. Spectators can join from anywhere at any time, and they might have very different terminal capabilities. Of course, they can also leave at any time. Those spectators who have AR, VR equipment or high-end equipment and are close enough to the players and enjoy good 5G local coverage might consume time-varying meshes directly from the vBroker. Other spectators see transcoded two-dimensional video where the service automatically maintains a mixture of transcoders with one transcoder per transcoding profile to optimize the total quality of experience for all spectators and to do it at the lowest price for the provider. Spectators also can move freely in the 3D virtual world, but they are unseen to the players and to each other. If a spectator joins from a remote location and she's the first one there, we span another broker at that edge and connect it to the main one, so that every frame produced by a specific transcoding profile is delivered only once over the expensive long-haul links. If an event of interest occurs in a game, a vReplay, a virtual replay CNF is being provided on demand. It creates a clip that shows, for example, how one player has grabbed a flag and how interesting it was from the sport point of view and so on. So you've got the idea, and I hope it's clear why serverless is a good paradigm for this type of workload. Mobile journalism is another use case, and as its name suggests, it's about producing a live contribution with production support functions set up on demand in the 5G edge itself, close to the event, basically. A journalist working for a broadcaster is involved in some newsworthy event, so she uses her application on the 5G mobile phone to talk to the part of the application running in the 5G media platform. Collaboratively, the application and the platform select an optimal edge to spawn production support functions based on the journalist selection of functionality. In this example, the journalist selects speech-to-text and face recognition functionality as supporting production. The choice can be different in another session, or it can change in the ongoing session. So after the edge is selected, the vSplitter, vDetect, and vSpeech are spawned as a function as a service, orchestrated to work together, and vSplitter is externally exposed as a service. The video comes into a splitter, the splitter forwards it to vSpeech and vDetect, which produce the metadata. Upon finalization of the session, the metadata and video are synced to the non-volatile storage, and the broadcaster is informed that the contribution is ready. The broadcaster fetches the files, merges them, edits them, and introduces them into the news program. Similar applications are in use today. So it's not such a big invention on the application side, but making a full production remotely, on demand, just in time, so that it shortens time to the news broadcast is a new opportunity for the broadcasters, and it can make a real difference for them. All right, so this is all good and nice, but when we say that the applications are executing at the edge, what do we actually mean by that? Conceptually, 5G media followed the ETSI multi-access edge computing MEC framework architecture. It's not important to understand every little detail about the MEC architecture. What is important is that there is a CNF for something that is called MEC platform. This CNF runs in close proximity to the 5G radio access network and offers services such as, for example, function as a service to the applications that run in the MEC hosts. This would be a good point to make a distinction between serverless that I used so far in this presentation and FaaS. Serverless is a broad concept, and when I say serverless, then everybody in this audience can think about something different. FaaS is a specific serverless programming model where the level of abstraction is a function, not a container or a service that scales to zero. So, for example, Knative is obviously a framework for developing serverless HTTP servers, but it's not FaaS. It's not function as a service. In general, every FaaS framework is a serverless framework, but not every serverless is FaaS. So OpenWhisk, that is the logo that is shown here, OpenWhisk was our serverless, was our FaaS framework, basically. Okay, so let's move on. A typical use case for FaaS in Mac is IoT. We pushed an envelope a bit and we use it for media-intensive applications. As I said, we use Apache OpenWhisk as our FaaS framework. The functions run on Kubernetes. So basically, Apache OpenWhisk offloads functions to Kubernetes. That's a standard feature in Apache OpenWhisk. And Kubernetes serves as our network function virtualization infrastructure. All aspects of Mac, including the application themselves, are managed by Mano. We used open source Mano OSM, and this OSM can be deployed anywhere. It can be deployed somewhere in the cloud, for example. So this is our environment in a nutshell. And at this point, you might be wondering, where is Argo? Where is Knative? And what about the orchestration? So we're just getting there. So remember, I told you that it was a journey for us. So initially, we created this OSM OpenWhisk plugin. And this allowed us to leverage Kubernetes networking and scheduling while maintaining high level of FaaS abstraction by using OpenWhisk. But then we understood that we cannot really orchestrate serverless applications with Mano. What we needed to do was to start some functions upon service instantiation. Potentially nothing should be started upon instantiation. Upon some event, for example, originated in the application itself, start more functions, configure the rest of the service to work with them. Then when these functions finish, they die out. So the service should continue. So it's reconfiguration. And we do it again and again and again with custom management flows. And we wanted to have for the network service developer and operator, we wanted to have for them the Kubernetes native experience. What we had with Mano was no real modeling concept for serverless, no custom management flows, no natural hooks to cater for events, no Kubernetes native DevOps experience. And increasingly, it felt like an exercise in futility because we were trying to orchestrate containers from outside of Kubernetes better than Kubernetes would do it itself. And that was exactly the point where we've discovered Argo about 1 year, 1.5 years ago. Now I need to walk you quickly through this animated diagram because understanding it is important to understanding the demo that I'm about to show. So we have Kubernetes, we have Argo workflows and Argo events installed. I spliced gateway and sensor controllers into one line, but they are separate controllers, of course. This is just for brevity. An administrator, or some application automation script requests an instantiation of a service package previously onboarded to OSM. Let's say, for the sake of the discussion, that the functions are, by the way, I should have called them CNFs, not VNFs. They're named Bootstrap, VNF1, VNF2, and VNF3. Bootstrap is a special function that service developer persona adds when she assembles services from individual VNFs. That's our invention, our addition to the method. And it will become clear in a second what we mean by that. OSM would unpack these functions in the order of appearance in the service package, one by one. So Bootstrap would go first, and VNF1, VNF2, VNF3, and so on. Now, each time OSM unpacks a VNF descriptor, it requests a fast Vim to instantiate it. In the background, there is a polling task that continuously polls Vim to get the metadata of the VNFs that it asked the Vim to instantiate, for example, IP and port of these VNFs. So, Bootstrap goes first, okay? And now the first thing that it does, it actually applies gateway and sensor YAML CRs to Kubernetes. And then what happens is that controllers of the gateway and the sensor pick the CR up. They are watching them. And then the gateway and sensor pods start executing. Together, this pair, gateway and sensor, is what we call serverless orchestrator. Now, the entry point for the serverless orchestrator is gateway. It's exposed externally as a service. And it's a private serverless orchestration for this service. It can be very customized to this service. Now, because of this polling in the background, the metadata about the gateway can be added to the metadata of the Bootstrap, this URL of the gateway. And now you can question OSM and get this URL, and this is your handle for orchestration. Now, at some point, an HTTP request just comes into the gateway asking to instantiate serverless, fast, VNF1 and VNF2. Okay, so what happens? Gateway passes it to sensor. There is a payload on the message with the operation and day 0 configuration, and sensor conditionally triggers Argo workflow that just does the orchestration. So here the Argo workflow appears, and it runs using the Argo workflow controller, and then instantiation and configuration of VNF1 and VNF2 just happens managed by Argo workflow. Now, after that happens, at some point in time, another request comes in, for example, to instantiate VNF3, and then a similar thing happens. It goes to sensor, sensor triggers another orchestration flow. Okay, because of this polling happening in the background, you see that the metadata such as IP and port of the functions also is propagated to the orchestrator such as OSM. Okay, so it's not very complex. So essentially, that was step 2 of our journey. So what we created on the right side, it's basically serverless orchestration based entirely on Argo workflows and Argo events to orchestrate everything we had to orchestrate in our use cases and across use cases, which was related to fast and event-driven activities. In this architecture, every service has its own customizable event-driven management and orchestration plane running entirely in Kubernetes. The service developer persona gets all these different CNFs from network equipment providers and assembles them together into services. And along the way, she can now create Kubernetes native orchestration flows with Argo, pack it in a standard way by using this Bootstrap configuration, just adding a couple of YAMLs there, which will bear this configuration when instantiated, would create this gateway and sensor. And bingo, you have your serverless orchestration for this instance of the service. All right. So this is all nice, but then we scratched our heads and said, hey, gateways and sensors would proliferate in this architecture, wouldn't they? Even if there are no events to orchestrate, the gateway and sensor pods are still sitting there and consuming resources. Yeah, it might be peanuts for one service, but across a portfolio, it can amount to some serious figures, and somebody has to pay for that, and it's not exactly pay as you go, right? So we decided to make both gateways and sensors Knative services, and I'll show you how it worked out in a second. You're welcome to check the repository that contains Knative events fork to see if what we did makes sense to you. Also, we'll be happy to hook up with Argo events folks to hear what they think. In any case, we thought maybe this can be a good feature in Argo events, irrespective of our specific use case. Okay, and now it's time for a demo. Right, so the demo will be based on use case of mobile journalism. This is just a recap. I hope you still remember this splitter, face recognition, speech recognition, RTMP server. In this demo, splitter, image, face recognition and speech recognition will be really fast functions, and RTMP is pre-instantiated. Okay, so let's see. Will be a very simple demo without OSM and also without OpenWhisk. We'll just spawn pods directly on Kubernetes. So we just apply gateway and sensor YAMLs as if that bootstrap function would do it, but we can do it directly, right? So that's exactly what we are doing now. So we've applied both gateway and sensor YAMLs, and they start executing. You can see it in the middle window. At this point, the service is onboarded on Kubernetes, and it's ready for orchestration, but there is nothing to orchestrate. There are no events, so why waste resources? Since our implementation is based on Knative for both gateway and sensor, then after a grace period, they should scale to 0. So let's fast forward a little bit. Oh, they start terminating. So gateway goes down first, scales to 0 first, and then the sensor scales to 0. So give it a little bit more. Yeah, let's fast forward. Okay. Yeah, so in the middle, so at this point, the service is there, but gateway and sensor are not consuming resources. And now to the orchestration part. On the left, you see the application progress, okay? So at this point, gateway receives an HTTP request asking to start a new session for mobile production, and the sensor triggers the orchestration flow that we follow in Argo GUI. We expose, in this demo, we expose every pod as node port, so that's why you see so many of them. And in the uppermost window, we can see which pods are actually running right now. So we see that splitter, the detector, the speech, everything is running, and there are some completed steps. These are pods that basically Argo was running to complete the management and orchestration flow related to the session. Okay, so at this point, everything is ready, and stream content starts go into the edge, into the splitter, and you see in the bottom window that media files start accumulating. We just use some test file here and just playing it, right? Just simulating a journalist. It's not a real event that we are showing you, but just some test. By the way, did you notice that in the middle window, the gateway and sensors started to terminate? Because there are no events right now to orchestrate, so they are not wasting resources anymore. They did the orchestration part, and now they scale down to 0 again. Okay, so at this point, basically, we are drawing to the conclusion, yeah, the stream is completed. And so the media files and metadata are created. And we just need to finalize the session, which includes maybe terminate, for example, creating the URLs for the files and notifying the broadcaster. So let's see what we've got in our test file.
Time is what stops everything from happening at once.
Oh, there is no
I wish I could
voice,
explain what it would be like for there not to be time.
That was not something that I was
But
expecting.
I can. We experience
anyway,
time. We are psychological
there
creatures
is
that have time. And that's
face
one of our defining
recognition here,
characteristics.
and
So
we have
if time weren't around,
talking, and these are the captions.
we don't really have even a good way to describe what happens. Because happens, right? That's a verb right there
so
that has to do with time. So I think once you start wondering about this, you get much further into the realms of philosophy than physics.
I actually don't think it's that mysterious. We live in a world that's full of stuff, and this world happens over and over again with the stuff in slightly different positions.
They're talking about time. These are physicists talking about time, so my time is up, or almost up. Thank you for your attention. This concludes the demo. And now I want to provide some remarks, some concluding remarks. So, first thing, Argo was a lifesaver for the project. We found it really delivering on its motto, getting things done with Kubernetes, and we love that. Remember, I was talking about the journey. So at this point in our journey, we started wondering that maybe we do not need other orchestrators at all. Maybe Kubernetes was just enough. And just see the demo that I've just showed you, right? Everything has been done by Kubernetes, Argo events, and so on. So indeed, what's the OSM role in this architecture? Or even if it was something else, for example, it was ONUP, for example, instead of it, what would its role be? Of course, there are many more topics than orchestration. There are, for example, OSS, BSS, governance, whatever, but orchestration, maybe we just need Kubernetes. And at the very least, I would say that even if traditional orchestration engines are still around, much more functionality should be delegated to Kubernetes, as it can complete a lot of stuff autonomously. I'm sure many people might disagree, but I'd rather spark a discussion about this. Another point is that we basically followed Mano mindset, because that's how we progressed in this project. And Mano is very workflow-oriented, but workflows are not really Kubernetes native style for orchestration. Admittedly, we pushed the envelope here. We used Argo for data pipelines orchestration. By the way, we are doing this in another project, but for network function virtualization orchestration. But if you want to be Kubernetes native, we need to have sort of never-ending workflows, because we never really deploy anything in Kubernetes and assume that applications components are continuously failing. So operators are more natural in Kubernetes, and we are looking at them, but we don't want to cancel advantages of the workflows. So this journey kind of continues, and hopefully next time we will be smarter and can share some answers to these questions that I pose. Until then, thank you very much for your attention, and I'll be happy to answer your questions. Hello. Hello. Thank you very much for coming to this session. It's a little bit like experiencing out-of-body experience. Kind of, I see myself from the outside, so I don't have the contact with the audience, and it's a bit difficult. But let me try answering your questions if you have any. So let's go to the chat. Let me go to the chat back. All right, so one question was about whether this is a reconstruction of the players. It was about the first use case that we have about TeleImmersive Media. Yes, it was a 3D reconstruction of the players. It's a time-varying mesh. It's a very heavy application on traffic. You cannot achieve it on scale for gamers without moving to this new generation of the network, of the mobile network, known as 5G. So it's a very 5G use case. These people are actually moving inside a virtual reality. It's a virtual world. They can move 360 degrees in this world. And this is what, there was also another question of what teleimmersive gaming actually is. It simulates your presence in this world and contact with other gamers. So basically, the next generation of these games is going maybe to have a haptic response, so that if somebody throws something at you in this virtual world, you're going to feel it, or you're going to feel pushback and stuff like that. So this is a family of use cases. Basically, it's not about gaming. It's also about learning. It's about teleconferencing. I think that if we had a platform like this at this time, then maybe our experience at KubeCon 2020 would look a little bit different. Maybe you could throw some things at me and I would feel it for my bad answer. So you would applaud and I would hear you, and all that without, special sensors, just using cameras and gestures and stuff like that. So any other questions? Okay, I'm familiarizing myself with this interface as I go. So question 7, I don't actually see it. So question 7, I don't see question 7. I only have okay, thank you. Are Argo functions streaming media, or are they just passing files? Okay, the role of Argo is in orchestration. You have two projects, right? Argo Workflows, which is currently a part of the CNCF sandbox landscape, I think, and you have Argo Events, which is not yet part of CNCF. In both cases, both Argo Workflows and Argo Events, they are just about orchestrating things, triggering resources in Kubernetes, and one of the resources can be a workflow. Now, the actual job is being done by containers, which we pack, which are obtained from serverless functions. So basically, the developer creates things like transcoders, for example, in whatever language of choice. We had some functions created in Python, and we have some functions created in Java, in Node.js, and we had something in C++. So basically, wherever you can, you just create these functions on the FAS framework, and then containers are created for you. You don't need to think about containers, and they are managed by Kubernetes. And by this, you can have all the advantages of the Kubernetes scheduling and networking and stuff like this. And with Argo, you can also have orchestration. But Argo itself doesn't have to do anything with streaming media or passing media or doing things like that. Wouldn't it be better to use OM Argo workflows instead of OpenWhisk to bootstrap Argo workflows instead of OpenWhisk to bootstrap the production of Argo events? I guess this general pattern can be applied also to OM Argo workflows. I'm not sure that OM Argo workflows have been around when we needed them, but we definitely, because the project actually started 3 years ago, but I think we definitely need to take another look at this. Thank you. Thanks for the lead. So thank you very much for coming. I will be lingering for another 15 minutes at least on Slack. And I'll be happy to take your questions from there. Thank you.